Let's talk about the end of the world. But what if I told you that the most powerful, most efficient, and most likely cause of a mass extinction event on Earth is completely invisible? What if the end of the world doesn't come with a bang, but with a silent, instantaneous flash that you don't even have time to register? What if the universe has a weapon that is not a bomb, but a sniper rifle fired from a galaxy so far away the light from its muzzle flash won't reach us for another million years? This sounds like bad science fiction, right? It sounds like a paranoid fantasy. It feels wrong. Our brains are wired to believe that for every effect there must be a local, understandable cause. And this is where our first debate begins. Because today we are talking about a phenomenon that throws that comforting idea of rules out the window. We are talking about a gamma ray burst, or GRB, and it is, without a doubt, the universe's most perfect assassination. Let's be brutally direct about what this is. A gamma ray burst is the most powerful type of explosion in the universe since the Big Bang itself. It is a focused, hyper-concentrated beam of pure, high-energy radiation more powerful than 1 trillion suns fired across the cosmos at the speed of light. In the first few milliseconds, the side of the Earth facing the burst would be subjected to a wave of gamma radiation so intense it would be like standing inside a nuclear reactor. But that's not the real killer. The real killer is what it does to our shield. As this beam of pure energy slams into our atmosphere, it would rip the molecules of nitrogen and oxygen apart. This triggers a series of chemical reactions that would, in a matter of seconds, completely obliterate our planet's ozone layer. Think about that. In less time than it takes to read this sentence, our protective shield against the sun's deadly ultraviolet radiation would be gone. The assassination is complete. But the execution has just begun. For years, even decades after the initial flash, the Earth would be bathed in lethal UV radiation. It would sterilize the surface of the land and the upper layers of the ocean. The phytoplankton in the sea, the very foundation of our planet's food chain and the source of most of our oxygen, would be wiped out. A global, systematic extinction event would be triggered not by a violent explosion, but by a silent, invisible sunburn. So, the threat is real. It is invisible, it is instantaneous, and it is absolute. This leads to the ultimate set of questions. Why do these cosmic sniper rifles even exist? What kind of cataclysmic event could possibly forge a weapon this powerful? How does it kill step by step from a distance of thousands of light years? And the final, most terrifying question, are we in the crosshairs right now? In this video, we will deconstruct this ultimate cosmic threat. We will take you into the heart of a dying star and the collision of two stellar corpses to show you how the weapon is made. We will walk you through the horrifying multi-stage execution of a planet. And at the very end, we will show you the real-time data from NASA's space telescopes, the Sentinels that are watching the sky for us, and give you the real scientific answer to the question, what are the odds? This is not a bedtime story. This is a journey to the edge of cosmic violence, and it starts now. An invisible speed of light beam of pure death. But a weapon like this, a sniper rifle on a galactic scale, doesn't just appear from nowhere. It must be forged in an event of unimaginable power, a cataclysm so violent it makes a supernova look like a firecracker. For decades, astronomers were baffled. What could possibly create such a focused, monstrous burst of energy? Today, after observing hundreds of these events in distant galaxies, they have identified two primary suspects. Two cosmic forges hot enough and violent enough to create a gamma ray burst. Suspect 1, the Hypernova, the death of a titan. We've talked about supernovas before, the spectacular death of a massive star, but what if the star is a true titan, a Wolf-Rayet star, for example, a celestial behemoth over 20, 30, even 40 times the mass of our sun, spinning at incredible speeds. When a star this massive runs out of fuel, its death is not a simple explosion. It is a hypernova. The star is now a corpse with a monster at its center, but the star is still spinning rapidly. As the outer layers fall inwards towards the newly formed black hole, they don't fall straight in. They form a massive swirling accretion disk inside the star itself, and this is where the weapon is forged. The black hole, now a spinning gravitational engine of insane power, begins to feed on the star from the inside out, consuming thousands of Earth masses per second. This process unleashes two colossal, tightly focused jets of pure energy and matter, blasting outwards from the black hole's poles at nearly the speed of light. Unbelievable. The star essentially becomes a cannon, and its own collapsing core becomes the gunpowder that fires a bullet of pure energy out of its poles. This is a terrifying thought, a star turning into a weapon aimed at the universe. A hypernova is a powerful candidate. It explains the immense energy. But it might not be the only killer out there. There is a second suspect, a scenario born not from the death of one star, but from the violent collision of two stellar corpses. Suspect 2, the kilonova, the dance of the dead. Imagine two objects, each more massive than our sun, crushed down to the size of Manhattan, spinning hundreds of times per second. Now imagine these two cosmic zombies are locked in a binary system, orbiting each other in a gravitational death spiral. The collision of two neutron stars is one of the most violent events in the universe. The resulting explosion, called a kilonova, is brighter than 1,000 normal novas. It is in these moments that most of the heavy elements in the universe, like gold and platinum, are forged and scattered across the cosmos. The jewelry on your hand was likely born in a collision just like this, but under specific conditions, this collision doesn't just create gold. It can create a short-lived hypermassive neutron star that immediately collapses into a black hole. And just like with the hypernova, if the conditions are right, this brand new black hole can unleash two powerful short-duration gamma-ray bursts from its poles, a final violent scream from the merger of two dead stars. So we have our two forges, the collapse of a single giant spinning star, or the collision of two dead compact ones. Both end with the same result, the birth of a black hole and the launching of a cosmic sniper bullet. We have built the weapon, we understand the mechanics of the rifle. But what happens when that bullet, after traveling for millions or even billions of years, finally reaches its target? What does that impact, that 10-second flash of pure energy, actually do to a planet like ours? The bullet has been fired. For millions, perhaps billions of years, it has traveled across the unfathomable void between galaxies, a silent, invisible needle of pure energy moving at the speed of light. And by a cosmic stroke of impossibly bad luck, our planet Earth is directly in its path. The time for suspense is over. The impact is now. Time 0. The prompt emission, the first strike. The gamma ray burst arrives. There is no sound. There is no explosion in the sky. The first thing that happens is a bizarre, eerie light show. As the high-energy gamma rays slam into the upper atmosphere, they collide with nitrogen and oxygen molecules. This collision creates a cascade of secondary particles and a phenomenon known as Cherenkov radiation. For a few terrifying seconds, the sky on the sunlit side of the Earth would glow with an intense, otherworldly blue light. It would be beautiful. And it would be the last beautiful thing many would ever see. Because in those same few seconds, the gamma rays are doing their real deadly work. They are acting like molecular-scale machine guns, shredding the most important protective layer our planet has, the ozone layer. The intense radiation systematically breaks the chemical bonds of the ozone molecules, O3, converting them back into regular oxygen. O2. Scientists estimate that a GRB from within our own galaxy could deplete up to 75% of the global ozone layer in a matter of seconds. Not just the part facing the burst. The atmospheric shockwaves would propagate the chemical reactions around the entire planet. Our planetary shield against the sun's deadly ultraviolet radiation, a shield that took billions of years to form, would be effectively gone. The first shot has been fired, the Earth's defenses have been crippled. Now comes the second, slower, and more insidious part of the attack. Hours to days later, the afterglow. The second strike. Remember, the initial burst was just light. But traveling just behind it at 99.9%, the speed of light, is a wave of super-accelerated matter, the shrapnel from the cosmic explosion. This is the afterglow. As this wave of high-energy particles washes over our solar system, it would be like flying a spaceship through the heart of a nuclear reactor. Satellites would be instantly fried. Astronauts in orbit would receive a fatal dose of radiation in seconds. On Earth, this particle storm would rain down through our now tattered atmosphere, creating a new, long-lasting danger global radioactive fallout. The entire planet would be bathed in a low, persistent level of radiation for months, even years. This two-part attack is incredibly efficient, a quick kill for one hemisphere and a slow radioactive poison for the other. If you had to choose, which fate do you think is better, the instantaneous fiery end or the slow, uncertain struggle in a radioactive world? It's a dark question, but let's see your philosophical take in the comments. But here is the horrifying counterintuitive truth. The real killer is not the gamma rays, it's not the radioactive fallout. These are just the accomplices. The true planet-wide executioner is an old familiar friend now turned into an enemy, the sun. The ozone layer was our sunglasses. The GRB has just smashed them. Now we are forced to stare into the full, unfiltered, lethal glare of our own star. The consequences of this are not immediate or explosive. They are slow, systematic, and will lead to a total collapse of the global ecosystem. And in our next chapter, we will deconstruct that collapse step by step. So, the assassination is a masterpiece of cosmic violence, a double tap. The first shot, the gamma rays, disables the planet's defenses. The second shot, the Afterglow, poisons the battlefield. The stage is now set for the final slow-moving killer to finish the job. This is the crucial part of the investigation, the part that connects this bizarre cosmic threat to our own planet's history. Don't go anywhere. This is the most critical concept to understand. The insane galaxy outshining energy of a gamma ray burst is not spread out over a giant sphere. It is channeled, focused, and directed into two narrow, tightly collimated jets blasting out from the poles of the dying star or the colliding neutron stars. Think of the difference between a bare light bulb and a laser pointer. A 100-watt light bulb illuminates a whole room, but you can stare at it from a distance. A 1-watt laser pointer can blind you instantly. Why? Because all of its energy is focused into a single, tiny point. A gamma ray burst is a cosmic laser pointer. It takes the total energy of a supernova and funnels it into two beams each, perhaps only a few degrees wide. The energy isn't greater than a supernova, it is just infinitely more focused. This sniper rifle model solves the energy crisis, but it introduces a new terrifying implication: directionality. This means that for every one GRB that we see because its beam happens to be pointed directly at Earth, there could be hundreds or even thousands of others that we never know about. They are firing their cosmic bullets all across the universe, but we are not in their line of sight. This transforms our understanding of the threat. The universe is not just a place where bombs go off randomly, it is an active cosmic shooting gallery, and we are just one tiny moving target among billions. This also leads to the chilling answer to the question, how close does it have to be dangerous, because the energy is in a focused beam. A GRB doesn't have to happen in our immediate cosmic neighborhood. Scientists estimate that a GRB explosion anywhere in our own Milky Way galaxy, a galaxy that is 100,000 light years across, if its beam were aimed directly at us, could trigger a mass extinction event. And this is where the story gets personal. We are not just talking about hypothetical threats from other galaxies, we are talking about our own cosmic backyard. And the evidence that one of these sniper shots may have already hit us in the past is disturbingly compelling. We'll get to that historical crime scene in the next chapter. So the weapon is not a bomb, it is a bullet. It is precise, it is focused, and it is invisible. How does it actually kill an entire planet? The initial flash of gamma rays is unimaginably powerful. Yes, but it lasts for only a few seconds. The radioactive afterglow is dangerous, but it dissipates over time. These are the violent, noisy assassins. But the true, silent, and most effective executioner is not the GRB itself. The real killer is the sun. This sounds like a paradox, but it is the horrifying, elegant truth. The gamma ray burst doesn't need to destroy all life on Earth. It only needs to do one thing: break our planet's sunglasses. That's what the ozone layer is. For billions of years, this thin, fragile shield of molecules high up in our stratosphere has been absorbing up to 98% of the sun's deadly high-frequency ultraviolet UVB radiation. It is the single most important piece of planetary hardware that allows complex life to exist on the surface. Without it, the sun's radiation would sterilize the continents and the upper oceans. Life would be forced to retreat back into the deep sea or die. The GRB is the ultimate ozone killer. The result is a catastrophic planet-wide depletion of the ozone layer in a matter of seconds. The sunglasses are not just cracked, they are shattered. The Earth is now naked, exposed, and completely vulnerable to the full, unfiltered fury of our own star. The assassination by the GRB is over. Now the slow, brutal execution by the sun begins. The first victim, the foundation of life. The first to die would be the most important life forms on the planet, phytoplankton, the microscopic, single-celled organisms in our oceans. These tiny creatures are the base of the entire marine food chain. They are also responsible for producing up to 70% of the oxygen in our atmosphere. The intense UV radiation would be lethal to them. As they die off en masse, the consequences would be apocalyptic. The food chain collapses. Krill starve. Fish starve. Whales starve. The entire ocean ecosystem unravels from the bottom up. The planet suffocates. With the primary oxygen producers gone, the oxygen levels in our atmosphere would begin a slow, inexorable decline. The second victim, the land. On land, the situation is just as grim. The UV radiation would cause catastrophic DNA damage to all surface life. Most plants would be unable to photosynthesize and would wither and die, leading to the collapse of the terrestrial food chain. Animals would suffer from severe burns, cataracts, and a massive increase in cancers. The world would not become a fiery hellscape. It would become a sterile, irradiated wasteland, a slow, agonizing death under a relentless, hostile sun. This brings us to the final sobering questions. With a weapon this powerful, this fast, and this invisible, is there any defense? Is there any survival plan? Or are we simply living on borrowed time, passengers on a planet flying through a cosmic shooting gallery? In our final part, we will confront these questions head on. How do you survive the unsurvivable? The answer in its most direct and brutal form is simple. You can't. Let's be unflinchingly honest. Against a direct hit from a gamma-ray burst originating within our own galaxy, humanity has no defense. We have no shield. We have no warning. The event travels at the speed of light, which means the moment we would detect it is the exact same moment it would sterilize our atmosphere. There is no time to run. There is no bunker deep enough. There is no protocol. It is a true, remember, a GRB is not a bomb. It is a sniper rifle. Its jets are incredibly narrow, perhaps only a few degrees wide. For us to be in danger, two incredibly unlikely things must happen simultaneously. First one of these rare cataclysmic events, a hypernova or a neutron star merger, must occur within a lethal range in our own galaxy. Second, and this is the critical part, the axis of that explosion, the barrel of that cosmic rifle, must be aimed with near-perfect precision directly at our tiny, insignificant solar system. The odds of both these things happening at the same time are thankfully astronomically low. Scientists estimate that a civilization-threatening GRB event might occur in our galaxy only once every few million years. We are living in a cosmic shooting gallery, yes, but the gallery is billions of light years wide, and we are a target smaller than a single grain of sand. Our greatest shield is not technology, it is probability. Lesson 2. The Sentinels, our eyes on the abyss. No, we are not blind, we are watching. Meet the true unsung guardians of our planet space telescopes like NASA's Swift and Fermi gamma-ray space telescopes. These incredible machines are our early warning system. They are constantly scanning the entire sky 24/7, waiting for that telltale flash of high-energy radiation. Swift is so advanced it can detect a GRB, calculate its position in the sky, and automatically pivot to observe it with its other telescopes all in less than a minute. Now let's be clear. These satellites cannot stop a GRB. If they detect one aimed at us, the warning would arrive at the same time as the burst itself. So what is their purpose? Their purpose is knowledge. Every GRB they detect from a distant galaxy is another piece of the puzzle. By studying them, we learn more about their frequency, their power, and their origins. We are for the first time building a statistical map of the danger. We are no longer just guessing. We are measuring the threat. This knowledge is what will allow future generations, perhaps with technology we can't even imagine, to develop a real defense. We are the first generation in history to not just stare into the darkness, but to begin to map it. And this leads us to the final, most profound lesson, the one that transcends science and touches the very core of our existence. The danger of the cosmic sniper rifle is not that it will kill us tomorrow. The real danger is that the fear of it will stop us from truly living today. So the ultimate survival blueprint against a gamma ray burst is not found in a bunker. It is found in a change of perspective. It is the realization that the most powerful thing we can do is to appreciate the profound, improbable, and magnificent miracle of right now, and understanding why this moment is so precious is the ultimate form of survival.